Hello. What I'm going to try to do here is to introduce the essential concepts of decision trees in 15 minutes. My goal is that you'll have an understanding of not only how decision trees are used, but also how they're fit, how they're actually generated from the data. So a decision tree in and of itself doesn't necessarily even have to be a model. It's very easy to think of a decision tree based on some knowledge that you have, some subject matter expertise, SME expertise. So I built this demonstration, this very simple decision tree just based on my knowledge of two-bedroom apartments in the Austin market. And basically, it's a set of nested conditionals that are going to tell me if a property is likely to be too expensive or not expensive for me to purchase. So what we have here is a bunch of decisions. Now, we start at the starting point and we look if square footage of the house is greater than 1,000, we decide it's expensive. That's likely what it's going to be. Otherwise, we have a second condition, which is that if it has more than one bathroom, it's expensive. Otherwise, it's not. This is really simple. You can go in as deep as you want on these. You can keep going. It doesn't really matter, though you'll find that sometimes going too deep actually has unintended consequences where you actually do a worse job. But either way, this is not how we're going to make decision trees just on what we know in our heads. We're going to make decision trees using data, and we're going to have a training set for decision trees. So let me go ahead and give you a little bit of a demo on that. So what we have here is really three axes of data. We have two features, x1 and x2. Features, as usual, are simply some, in this case, numerical information about each point. And then the third axis, which I don't have drawn as a line, but I have it shown as color, is the category of the point. And to fit a decision tree to this, what we do is we split the points with lines. So here we have 1, 2, 3, 4, 5 splits on the x1 axis. And what we're going to do is we're going to score every split. The way that we score every split is we start out by deciding what color wins each split if the points vote. So on the left-hand side, there's only one point, the blue point, and it definitely wins the first split because it's the only voter. On the right-hand side, we see that there's 3 votes for red and 2 votes for blue. And what we look at here, well, here there are 2 misclassified points. These are in the minority class. So then what we do is we count out the misclassifications and members of the minority class in each region. And we look at the misclassification rate. So in this case, there's 2 misclassifications on the red side, on the right-hand side, and no misclassifications on the left-hand side. So we have a misclassification rate for that split of 2 out of 6. But we don't just do this for that split. We do it for every single one of our split. So let's look at one more of these as an example. So let's take this as our split. The left-hand side then is blue because it only has 2 points. The right-hand side is red because it has 3 red and 1 blue. So since this is blue and this is red, we have 1 misclassified point. This is a little bit better than 2 misclassified points. And I've also done this for the other 3 splits. And those were the misclassification rate for each of those splits. Now, we don't have to do this just, or actually we shouldn't do this just on one feature. We want to evaluate every split of every feature. So let's look at the splits along the x2 axis, having found that the 1 and 6 is the best one on the x1 axis. I've also gone here and I've taken each split and I've determined the misclassification rate that split would give. So now I found the first split of my decision tree. It's this one in the center. which has a misclassification rate of 1/6. And so here I have the first split of my tree. But I can keep doing more splits on my tree, which is I simply recursively split each side. I basically train another decision tree. I evaluate every split for each side. Now on the left-hand side, there's no point to making any more splits because we already only have blue points there. On the right-hand side, however, there's a number of splits we could consider. We could consider any of these splits, though somewhat obviously, either this split or this split will do the best in that subregion because that one completely separates the blue point. So here I have a tie, and to break ties, it doesn't matter what I choose. So I'm going to end up choosing this one as my best split. And this is the decision tree when it's done. Anything that's in this blue box, this model will predict to be blue. Anything that's in this red box, this model will predict to be red. And anything in this other blue box down here, the model will predict to be blue. And that's it. Just to show you that this is in fact a tree, we can see that it's a tree. So this is the first split. It looks, everything to the left-hand side is blue. So here, anything that's less than this particular value of x1 is blue. So that's what happens on the left-hand side. On the right-hand side, anything on the right-hand side, well, there has to be a second decision. But to go right, if you're above x1, you go right. So if you're above x1 star, rather, you go right. And then you look at it between the other split. So anything below x2 star, this particular value of x2, we go to the left, getting blue. Anything above that value, we go up, or in the view of the tree to the right, and we categorize as red. And that's really it. Decision trees are fairly simple. Now, it's worth mentioning, in this particular example, I used a metric that was really easy to calculate. I used the misclassification rate to choose the best split. In practice, there's a few other ones that are more commonly used. One is called the Gini coefficient, and then the other one is called entropy. But the idea is the same. Basically, I score each split, I count the degree of inequality by some metric or another of each split, I choose the best one, and then once I've chosen the best one, I do this recursively. I keep going and I make more and more splits. So at this point, let's move on to an applied exercise.